Alright, so today we're going to be looking at lesson 2.9 and we're going to be dividing radicals. Alright, we've been multiplying radicals, we've been subtracting radicals, we've been adding radicals, and so now what we're going to do is we're going to try to divide those radicals. Alright, so as always, we're going to take a look at a little warm-up here. So in this warm-up, it wants us to multiply these radicals together for both of the examples, what we were looking at yesterday. So yesterday we know that we multiply the outside to the outside, which is going to give me 30, and I multiply the inside to the inside. Okay, so I'm going to just write this as 15 times the square root of 35. So if I continue to factor this out, you should see that I get factors, or you can get factors of, and I'm just going to bring this 30 down. So this is going to be 30 times the square root of 3 times 5 times factors of 35 would be 7 and 5. Alright, and so you see I can't break this down anymore. So I see very clearly that I have a pair of 5s. So I can pull a 5 out of the radical. And so this becomes 30 times 5. Well, over here, I'm just going to go off to the side and do 30 times 5. Okay, which gives me 150. So 150 times the square root of, well, you can't do anything with the 3 and the 7, so therefore they have to stay under there. And when they stay under there, you multiply them back together. So this gives you 150 times the square root of 121. And with the second one over here, same thing. I don't have any numbers on the outside, so I just basically multiply the 18 and the 60 together. Instead of multiplying them together, I'm just going to keep them separate because I'm going to end up having to try to factor out these numbers anyway. And so I'm going to factor each number. For the 18, that factors to 9 and 2. And for the 60, I'm going to use 5 and 12. And you guys know how to use your calculators to get factors if you need them. But I'm just coming up with these factors off the top of my head. But you can go back and double check me. And so I'm going to break the 9 down further. The 9 breaks down into 3 and 3. And the 2 breaks down. Well, the 2 doesn't break down. It's already just simplified. The 5 is simplified. And I can break this 4 down into, this 12 down into 3 and 4. And not 34, but 3 times 4. And so I can now break this 4 down to, let me rewrite this. So 3 times 3 times 2 times 5 times 3 times 2 times 2. And the 2 times 2 came from where I broke the 4 down. So now I find my pairs. I have a pair of 3s, and I also have a pair of 2s. So that means I can pull a 3 out. That also means I can pull a 2 out. So that's a 3, and that's a 2. So when you pull those numbers out, they multiply together. So that's going to be 6, because you pull the 6 out of there. The 3 and the 2 out, and the 2 times 5 times 3 stays under there. So you can just multiply them back together and you should get 6 times the square root of 30. Okay. Alright, so let's move on with today's lesson. Alright, so today what we're going to do is we're going to be dividing these radicals. And so to divide these radicals, the idea of it is saying that if I have a radical, or if I have a radical and it's over something that's being divided, like A and B, I can rewrite them individually. Okay, so I can write this as the end root of A over the end root of B. And we know that this right here is our index number. Okay, this is our index number. And so the index number, since they're written separate, is still the same index number. Let's take a look at an example of what I'm talking about. So we have here the third root of 3 divided by 8. Well, I can rewrite this as the third root, and you got to make sure you put your index number in there. So the third root of 3 divided by the third root of 8. Okay. And so when you get this, well, quite naturally, I want to try to simplify the top, which I can't do anything to the top because 3 is a prime number. I can't break it down. So the top of the fraction just stays as the square root of 3. I mean, not the square root of 3, but the cube root of 3, or the third root of 3. All right, now the bottom part I can break down, and so you guys should know that you can break this 8 down into 2 times 2 times 2, and it is still the cube root. And so the cube root tells us that I can group together 3 numbers. If I have 3 numbers, 3 of the same numbers, I can group them together and pull one out. So quite naturally, you see that, well, that's all you have on it there is just 3 2's. So therefore, the cube root of 8 is just 2. Okay, so guess what? That simplified to just 2, the bottom part, and the top part, it's just going to stay the third root of 3. Okay, so I cannot do anything else to the top. I can't do anything else to the bottom. They can't divide each other because I have a whole number, cannot divide something that's inside the square root. Okay, so therefore, this is completely simplified. There's no radical in the bottom. Look at that. The radical is gone. So when we're simplifying these division, or when we're dividing these radicals, the idea is to remove radical from bottom. Of fraction. Okay, so if I know that I've done that, then I know that I kind of simplified it. All right, and that's what we did here. Okay, let's try to look at another example here. So as you can see, you have 4/8, or 4 divided by 8, or 4 times the square root of 14, and then divided by 8 times the square root of 2. Now, there are several different things that are going on here that you can think about. What I want to do is I want to treat these as fractions. All right, so follow me. So this is a fraction. Quite naturally, I want to divide these two numbers. Okay, and if you divide those numbers, you have to start from the top to the bottom. So this says 4 divided by 8. So when you put it in your calculator, you put 4 divided by 8. And you should get 0.5. Some people are so tempted to put 8 divided by 4 just because I think they see that 8 is the bigger number, even though it's at the bottom. You got to read the problem for what it is. So 4 divided by 8, you get 0.5. Okay. Now, and in your calculator, the TI-84 calculators that we've been working with, I can turn that 0.5 into a fraction. To do that, I'm going to hit the math key, and then I'm going to select number 1 for frac. So I'm going to hit enter, and then I'm going to hit enter again, and it turns it into a fraction. So therefore, 4/8, okay, because this is a fraction, 4/8, okay, can be rewritten as 1 over 2. Now, what's so interesting is the 14, or the square root of 14, is still connected to the 1, and the square root of 2 is still connected to the 2. So some of you notice that this is not simplified all the way because there is a square root that is still in the bottom. All right, so the question is, how can I get rid of this square root? So what we can do, we call this rationalizing the denominator. And so what that tells us to do is to just multiply both the top and the bottom, by whatever square root is on the bottom. So in this case, I have the square root of 2 because of this square root right here. So I'm going to multiply the bottom by the square root of 2, and I'm going to also multiply the top by the square root of 2. Okay, when I do this, on the top, I get the square root of 28. All right, so 2 times 14 is 28. And on the bottom, I get 2 times the square root of 4. Now, some of you guys might say, well, where did the 1 go? I don't have to put a 1 there because if there's no number written in front of it, you should automatically know that there is a 1 there. Okay, so now I can try to simplify because my whole object of this is to try to remove that radical from the denominator. So if I simplify the bottom, I should know that the square root of 4 is just 2. So basically, in the bottom, I'm just multiplying 2 times 2. Well, in the top, I can break the square root of 28. If I want to go here and look for factors of 28 divided by x, I can. So I'm going to do that. I'm going to hit second graph, and I'm going to try to look for perfect squares. And guess what? I found one. So 7 and 4. Okay. So instead of writing 28, I'm going to write the square root of 7 times 4 at the top. So now, when I rewrite this, at the top I get the square root, or I get 2 times the square root of 7 at the top. And on the bottom, I should just get 4. Now, hope you guys seen what I just did. The only thing that I did was I took the square root of 4 because I knew that 4 can be broken down into 2 and 2. All right. And then I can pull out a pair of 2's. Okay. So by this point now, you guys should be very familiar with simplifying square roots. So now you notice that the radical is gone, but here I have whole numbers that I'm still dividing. So I can deal with these whole numbers. So let me divide those. So what am I going to put in my calculator? 2 divided by 4, because that's what it says. And I get 0.5 again, and I'm going to turn that into a fraction, and I get 1/2. So therefore, this is equivalent to the square root of 7 over 2. All right, and so I just simplified that. Let's look at another example. All right, so here we have the square root of 7 divided by x over, the square root of 7 divided by x. So I can rewrite this as just the square root of 7 over the square root of x. All right, so now remember we said that we have to get rid of the radical in the denominator. How do we do that? And by the way, we call that rationalizing the denominator. Okay, we want to rationalize the denominator. And I don't expect you guys to remember that, what it's called, but you need to know that you need to get rid of that radical in the bottom. So to get rid of that radical, we got to multiply both the top part and the bottom part by the radical in the bottom. Okay, so when you do that, at the top, you should get the square root of just 7x. And in the bottom, you should get the square root of x squared. Okay, or x times x. Now, when I'm simplifying this, I see at the top, I can't simplify anything. So it's just going to stay written as the square root of 7x. And in the bottom, it becomes just the square root of x squared is just x. So you can't do anything else to it. There's no numbers to divide. So